Hello everybody. I will try to mention about my PhD journey today, which is related with the aligned carbon fiber with thermoplastic matrix for forming of them. How we came to this point is as the Mehran mentioned before, we need to have sustainable solutions for the composite structure. And one of the possible solution is using a thermoplastic matrix, but the current manufacturing methods has problems with the thermoplastic matrix, and one of the solution can be is the forming, but the continuous fiber is hard to form, and where we can use the hyperdiff here is the short fiber alignment method. We can align the fiber and keep the mechanical properties close to the continuous fiber while keeping the formability of the short fiber composite at the same time. So my aim is for my PhD is creating a forming simulation to make these material defect-free formable with using the simulation. As the C1 mentioned, I am using a similar simulation method developed by Adam Thompson, which is separating the bending and the tension properties. So for this model, I need to introduce some directional properties to the simulation. My model is slightly less intelligent compared to the C1 one. And for this one, we are focusing on more tensile properties different than the continuous fiber, because the continuous fiber has the shear locking mechanism, while in this one, short fiber has the separation other than the continuous fiber. We did different tensile test experiment with the different speed, increasing the speed 10 times each time, and while using different temperature between the TG and the melting point, while the specimen still can carry load and it is formable same time. What we realized is that as it expected, when we increase the temperature, load carrying was dropping. But when you try to form it quickly, it was carrying more load. So we wanted to model it as a micromechanical, with the micromechanical model, and we examined the matrix, focused on the matrix because the load carrying mechanism between the short fiber go through the matrix by shearing the matrix. So we examined the matrix with the shearing properties with different crystallinity, and we try to improve the micromechanical model. After improving the micromechanical model, we wanted to validate it with the different temperature and the different loading to be sure that our correction factors is also fitting well with the different settings where we don't know the temperature. We did the experiment at 80, 100, 120, and 140. But for the validation, we used the 90 degree and the 110 degree. Because of the viscoelastic properties of the PLA, we also wanted to see the relaxation during the experiment. So we loaded the specimen 30 seconds, stopped the experiment 30 seconds, and load it again. And we tried to capture it with the simulation. And we had a good correlation between them. And finally, we kind of characterized the tensile characterization for this material. And for following these works, I need to implement the bending and the shear mechanism with the same kind of correlation into the simulation to simulate the full full forming experiment and the simulation. You can see the few bending experiment in the left-hand side, and the center is the shear experiment. And I will be doing the forming experiment with the forming rig at the left-hand side in the future, and I will compare with the experimental and the simulation results. Thanks for listening. I am happy to answer your easy questions here. If you have hard questions, my poster will be there. We can discuss there.